Now to the last topic, Topic 8 of Module 1. We will be reviewing this and hopefully have your textbook. And what we'd like you to do is read these 8 statements, and then if it's true, you put a plus. And if it's false, you put a minus. Or you could use F and T. All right, let's give you some time. Look this through and we'll call on people. Now, I tried these on my own and I did miss one. Again, they're a little tricky. So let's take a look and you can compare what you've got. We're saying that the absolute value of x is never negative. And that's true. The absolute value of x always has to equal a positive. Now, this one's a little tricky because it's saying the absolute value of x is always positive. Well, here they're referring to that x inside that could have been negative. So therefore they're calling that one false. Now, in number 3, if x is negative, then the absolute value of x, once we convert it, would be a negative x. Now, normally they write this way to ensure that. They'll put the negative outside. They're not showing that here, so again, that's a little tricky. Number 4, the distance between A and B can be expressed as the absolute value. Remember, distance is always going to be positive, so that's true. And by definition, the absolute value of something is that many units from 0. It's a counting number, so it's always positive, and that's true. In number 6, there are 2 solutions of the absolute value equals this. Remember, we write it without the absolute signs equals 17. Write it without the absolute signs and we say this is a negative 17. So we get 2 answers. This one's tricky because here it's saying the absolute value of this is greater than a negative 5. Now, when it's greater than negative 5, well, it's starting at negative 5, but then it goes to 0, 1, 2, 3, 4, 5, and those would be solutions. So the answer is there is no solution is false because there are solutions when it's greater than. The key here is this sign, this inequality sign. When that is written this way, this is there are solutions. Now, for number 8, all real numbers are solutions of this. Now, when they're saying the absolute value is less than a negative, we said over here absolute values are never negative. And because you're starting with a less than and negative 3, there can never be positive values. This is false. Okay, a good review, and again, concepts, definitions, theory of what's needed to be successful in dealing with absolute value. Again, using your textbook, let's see if we can match these up. We'll pause. Our previous review was helpful for this too. So as we look at this, we said we remove the parentheses and write it this way. or the absolute signs, remove the absolute signs and put a negative there. So that's G. Here again, we remove the absolute signs and write it this way. Remove the absolute signs, reverse our direction, and put a negative, and that's letter H. And they're saying you could put this in the middle and set it up this way. That one's a little tricky too. All right, now for this one, we remove the absolute signs and write it this way. Remove the absolute signs and write it that way. Now this one is if you remember, is a disjunction. This one was a conjunction. They're not asking that, but a little review. All right, number 13. Again, for 12 and 13, since this is less than, there is no solution. And we can't have an absolute value equal a negative. And for this one, again, we're going to, since this is a greater than, for these, we say the solution is the set of real numbers. This one's a little tricky too, because it has that absolute sign and a negative, but because it's greater than, we're saying this could be the set of all real numbers. All right, let's go on to some others. Now for these next examples, we're looking at this particular graph, and an interesting thing about what they're showing us here is to use this notation. Y sub 1 is this, so absolute value of x plus 2. Now y sub 2 is equal to 3. So in a sense, we can write it this way. So, well, let's put a 3 there. So how do we solve that? Well, we take away the absolute signs. We write it that way, and then we write it again. Take away the absolute signs. And then it's the opposite sign of 3. Could be a negative 3. So when we solve this, we get x equals 1. Here, x equals a negative 5. And that's what they're showing you in the graph. So if you would to put that, and then keep in mind now your y here is 3. 1, 2, 3. So when y is 3, and this is absolute value, what answers do you get? And there it is. And these others are done in a similar way. Notice that number 20 is a little tricky. In fact, they're trying to trick you. They're saying the absolute value equals a negative 1. Again, for this, there's no solution. And the others are all good here. Okay? Now notice this is an equal sign, but these are inequality signs. So you're going to get inequalities in some cases. All right, let's go on. So for number 21, it's x could be a 7, x could be a negative 7. Here's one of our aha. X, can it ever equal initially a negative? And the answer is no. And here there's just the one answer of 0. So here you would write it this way, without the absolute signs, equals 4. Write it this way, equals a negative 4. This one is, since it's negative, there's no solution. All right, well, we're just at 10 minutes, so we'll wind this one up.